Dr. David Fajgenbaum is in the fight of his life.
Our biotechnology industry is a national security asset.
But there's something slightly wrong. They suffer from a rare and baffling genetic disorder.
The UN's latest report on global hunger shows we're moving backwards.
New weight loss drugs have their impact goes far beyond just weight loss.
They're referred to incorrectly.
We're a nation living longer and longer.
Welcome to the first episode of our new season. True to form, this season we continue to bring you the latest in biotechnology breakthroughs that help people and our planet. From patient stories to national security issues to food security and more. We promise to keep you informed and your headphones glued to your ears. First up is a story about a doctor who becomes a patient. We take you through his journey, his extraordinary fight for his life, and what he discovers along the way. I'm Teresa Brady, and you are listening to I Am Bio.
There's an old saying that doctors make the worst patients, but one man may be proving them wrong. In 2010, when he was a medical student, he was diagnosed with a rare, life-threatening disorder called Castleman disease. Multiple times, it looked as though he was going to die. In fact, once his family even called in a priest to give him his last rites.
My name's David Fajgenbaum. I'm a physician scientist at the University of Pennsylvania, and I'm also the co-founder and president of Every Cure.
We all have unique stories, but David's tops most of them. In some ways, he really shouldn't even be here at all. What makes his life story remarkable begins in his early adulthood. Up until that time, David tells us, his life was notably unremarkable.
Grew up in Raleigh, North Carolina, with two amazing older sisters and two incredible parents who supported me through everything I did. I was very fortunate growing up. Never had any health issues myself or in my family, and I was laser focused on one day being a college quarterback. All I could think about was being a Division I college quarterback, and so I trained relentlessly. In fact, I was in incredible shape. I trained all the time. My nickname was The Beast because I worked out so much. Totally healthy, no medical issues whatsoever.
David's dream of playing football in college was realized when he was recruited by Georgetown.
I was recruited to play football at Georgetown, and we're certainly not known for our football at Georgetown, but we are Division I, and for me, it was so special to achieve that goal.
David says his first crushing and most difficult challenge came shortly after starting at Georgetown.
Everything in my life changed just a couple weeks after I got to campus when my mom was diagnosed with brain cancer, and that just crushed my soul. It changed everything about the trajectory of my life. Rather than focusing on will I play college football one day and how far could I throw a football, that became so unimportant. And all of a sudden it became, can I be a part of discovering drugs to help patients like my mom? Watching her suffer in her battle with brain cancer just set me on a mission, on fire, to figure out as many drugs as could possibly help patients like her. I spent as much time as I could with my mom while she was sick and just grieved her passing 15 months after her diagnosis.
David explains that it was then that he decided to train his sights on medical school, with the hope of fulfilling the promise he made to his mom to help patients like her. He enrolled in the University of Pennsylvania's medical school. He was well on his way to becoming a doctor when things changed.
So after college at Georgetown, I went to Oxford for grad school, and then I came back to the U.S. for medical school at the University of Pennsylvania. And I was a third-year med student, well on my way towards becoming a doctor like I had promised my mom. And I was actually on my OBGYN rotation, so I was helping to deliver babies into the world, kind of what I consider like the pinnacle of medical school. And out of nowhere, I just started noticing I was more tired than I'd ever felt before. And of course, as a medical student, everyone's tired, but it was a fatigue that I'd never really felt before. I noticed lumps and bumps in my neck. I noticed this horrible abdominal pain, fluid pooling around my ankles. And it was just so unusual for someone as healthy as I had been to start having all these unusual symptoms. And the fatigue got unbearable. So I remember I went from taking an exam for OBGYN to then going down the hall in the hospital that I was working at and going to the emergency department. They ran some blood tests, and my doctor came in the room and said, "David, your liver, your kidneys, your bone marrow, your heart, and your lungs are all shutting down. we have to hospitalize you right away. And that became the start of what would be months and months hospitalized with this horrible disease.
But what was this horrible disease that very nearly killed him? David says it was not obvious to any of the doctors what he was dealing with.
It took about 11 weeks of me being in critical condition in the ICU, literally with all of my organs shutting down. A retinal hemorrhage made me temporarily blind in my left eye. I gained almost 100 pounds of fluid. I needed transfusions to keep me alive while I drifted in and out of consciousness. But thankfully, 11 weeks into that, really at the last possible moment, the doctors finally came up with the diagnosis, idiopathic multicentric Castleman disease. And it really came at the last possible moment. In fact, I had my last rites read to me right then because my doctors were certain I wasn't going to survive and I was really out of time. With the diagnosis, I got some chemotherapy, which got me into remission.
Unfortunately for David, his remission was only temporary. It didn't last.
A few weeks later, I was back in the ICU again. And this became a pattern where over the course of about a 6-month period, I had 3 of these deadly flares of the disease. I almost died 3 times. And then, unfortunately, I would get into remission thanks to chemotherapy, but then I relapsed even 2 more times. So over the course of a 3-year period, I had 5 deadly hospitalizations where each time my doctor said, he's not going to make it, say goodbye. So I hugged my family, I hugged my friends. As I mentioned, one of those times a priest came in and read me my last rites. But this disease was relentless, and it just kept coming back.
Castleman disease is not a one-size-fits-all. David has a subtype called idiopathic multicentric Castleman disease, or IMCD. With this type, there's no triggering event like cancer or a virus. The immune system gets out of control for some unknown reason. And when it's out of control, it attacks all the vital organs, basically until the patient dies, unless there is some intervention like chemotherapy. But as David says, multiple and constant rounds of chemotherapy are not sustainable. It was time to take matters into his own hands.
So I had my 5th deadly flare of the disease in November of 2013. At that time, I had finished medical school. I had started business school at Wharton, and I'd been collecting blood samples on myself every couple of weeks. I was storing them because I thought if I relapse, I really need to have blood samples so I can run experiments on them. So I did relapse, and this time I got a combination of 7 chemotherapies to try to save my life, and they just barely were able to save my life. When I got out of the hospital, I went to the lab and I thawed all those samples, and I did a series of experiments called serum proteomics, flow cytometry, then eventually something called immunohistochemistry on one of my lymph nodes. And from those experiments, I got a signal that a particular communication line in the immune system called mTOR was turned into overdrive. So I thought to myself, well, what if I could turn off that alarm system or communication line in my body, which I know it's turned on? Maybe that could prevent this disease from rearing its head. Maybe that could prevent my immune system from attacking my body.
In this race against time, David describes how he and his doctors began to look for drugs that were already approved by FDA for other indications.
I didn't have $1 billion in 10 years to make a new drug. So I had the simple thought that maybe there's some other drugs out there that could treat my disease even if they weren't made for my disease. And there were drugs that already existed that are able to turn mTOR off. The most famous one is a drug called sirolimus or rapamycin. That drug was discovered on the island of Rapa Nui decades ago, and it was figured out that it was really good for preventing organ transplant rejection. So that's what the drug is made for. It's what it's approved for. And the way it works is by turning off this basically alarm system or communication line. So we decided to try this drug, sirolimus, for the first time ever. Anyone with my disease, I started taking that drug. And this July 5th marked 10 and a half years that I've been in remission on this drug. After nearly dying 5 times in the 3 years before starting it, now it's 10 and a half years of remission on this drug.
That's truly remarkable and a testament to the power of science, determination, and the will to live. When we come back from a break, we talk with David about how he's helping other patients with rare diseases by applying what he learned from his struggle and eventual conquering of Castleman disease. A bio membership can take you and your company to the next level. Listen to what Calicyte's CEO Elaine Haynes had to say at a recent bio-hosted event.
The advocacy that Bio does on behalf of our industry is critical to make sure that the drugs that my company is developing now, when they get to market, will have the proper construct for them to be successful.
Visit bio.org/join to learn more. As fortunate as David and his doctors were to discover sirolimus, the discovery would not have been possible without painstaking and relentless research. By his 5th relapse, David had somehow managed to complete medical school and nearly finish Wharton Business School. During this time, he was either in the ICU fighting for his life or in remission and treating patients. In the evenings, he ran experiments. If David did not take on the fight for himself, he probably wouldn't still be alive. His medical knowledge, research, and sheer determination contributed to his success. Now he says he is heavily invested in applying this strategy to other rare diseases.
Shortly after discovering that sirolimus could save my life and doing the research to uncover that, I joined the faculty at the University of Pennsylvania and set up a center called the Center for Cytokine Storm Treatment and Laboratory with the goal of studying Castleman's and diseases like Castleman's to see if we could find other drugs that are already available that could be repurposed for these deadly diseases. And I am just so proud of the team that we built here and all that we've accomplished. We've been working on this at Penn for about 9 years, and we've led repurposing efforts for 14 different treatments for diseases they weren't intended for. That 14, that includes sirolimus. And it's just been incredible to see patients come to our center without a drug, without a treatment, and then uncover a treatment that could work for those patients and then expand it out to other patients with their disease. It's just been such an honor to be able to go from first chasing my cure, discovering a drug for me, but then expanding it out to chasing cures for related diseases.
The advent of AI brought new opportunities for David and his collaborators to chase cures for rare diseases. He tells us about a relatively new initiative that is already showing progress.
About 2 years ago, we decided that we didn't just want to focus on Castleman's and diseases like Castleman's, but I co-founded a nonprofit organization called Every Cure, along with Grant Mitchell and Tracy Sikora, to utilize the incredible new technology from artificial intelligence and machine learning to not just look for drugs for a few diseases, but actually to look at the potential for every single drug to be able to treat every single human disease.
David describes why AI is fundamental to the research Every Cure is doing.
In the 10 years before starting Every Cure, my lab has worked basically around the clock to be a part of identifying and advancing 14 repurposed treatments for diseases they weren't intended for. And we're so proud of that. Our lab's going to keep doing that here at Penn. But when you think about the incredible unmet need, there are 20,000 human diseases, the vast majority of which don't have a single approved therapy. It would take many, many, many years for labs like mine to unlock even a fraction of all the diseases that are waiting for therapies. And that's why the advent of artificial intelligence and machine learning to the extent that it is now has been so transformative. So we organize everything the world knows about everything in medicine, science, biology, every gene, every protein, every disease, every chemical. Imagine creating a two-dimensional map that lists all of those concepts and then lines connecting all of them. Imagine connecting everything that's known about everything in one place. We apply 5 different AI algorithms to these biomedical knowledge graphs, and it gives us a score from 0 to 1 for every drug versus every disease. All 3,000 drugs against all 20,000 diseases, meaning that within one day, we can calculate 60 million scores from 0 to 1 to tell us whether the drug likely works for that disease or not. If we did that manually the way that we do things in my lab, it would take thousands of years to do that. We can do that in one day with artificial intelligence. Now, that doesn't mean that every prediction in there is going to be perfect and everything that gets a 0.99 is going to work for that disease and everything that gets a low score is not going to work for that disease. But what it does mean is that using the latest and the greatest AI technologies, we can come up with the drugs that likely work for diseases, and then we can focus in on the ones that we think are going to have the greatest impact, the least expense, that we think are going to be the safest opportunities. And it's this completely unbiased approach to say, how can we just help people? And there's no way we could do this without AI.
David shares a poignant story demonstrating that Every Cure's research efforts are not just theoretical.
a patient named Joseph who was battling from a disease called POEM syndrome. He was in the hospital and then transferred to the ICU in January of this year, and his doctors were getting ready to transfer him to hospice care on Monday. So this was a Saturday, and we were contacted actually on the day before, on that Friday, by Tara to say, my husband's about to be transferred to hospice care on Monday. Nothing's working for his POEM syndrome. I've heard about this program that you've built through Every Cure, and POEM syndrome has some similarities to Castleman disease. So maybe you'd be willing to look at your scores and maybe reach out to his doctor and recommend a treatment. And so we did that, and I reached out to his doctor on a Saturday, and his doctor very kindly took my call, and I shared with him a couple drugs that were scoring very highly in our algorithm that were made for a disease called multiple myeloma, which is actually a very similar disease to POEM syndrome. And they were scoring highly in the algorithm based on similarities between the diseases. And Joseph's doctor decided to prescribe these 3 drugs for multiple myeloma for Joseph's POEM syndrome, really in a last-ditch effort to see if they could work. And a couple days went by, I didn't hear any updates, and we were sort of brokenhearted. We just assumed that they didn't work. And then we got the phone call from Tara to say that they worked, and that not only was he out of the ICU, but he was in the hospital, and they were talking about, discharging from the hospital and just a couple weeks later. And Joseph's now home with his family, doing so well.
The Every Cure model is truly unique in drug development. As a nonprofit, it is unlike traditional approaches of drug companies that typically focus on targeting specific diseases and attracting investors with the promise of a potentially substantial return. In fact, David says that although many people like the concept, few are willing to actually invest.
As a nonprofit organization, we don't own any of the drugs that we're advancing. One of my co-founders, Grant, and I, we often joke that Every Cure is the largest drug company in the world because literally every drug that's ever been made by any drug company and is approved is in our pipeline, all 3,000 of them. But we're also the smallest drug company in the world because we don't own any of those drugs. It was a long road to receive funding to really get going. It took us about a year before we raised our first $1 million. And so it wasn't that anyone told us not to do it. It's just no one would actually give us the money to do it. So most of the people we'd speak to would say, we love your idea. How can I invest? And we'd say, well, it's a nonprofit. Well, you can invest in us, but we can't give you a return. So as a nonprofit, you're not going to be able to profit off of what I think is a great idea. And they think it's a great idea too. And they say, well, we're not going to put money in if this can't be an investment where we could get a return. That was one group of folks. Another group of folks said, I love this idea. I would love to give to what you're doing if you can promise that you're going to focus on this particular disease of interest. So, maybe someone in my family had a particular disease, and I would love for you to find a drug for that disease. And we would love to find a drug for that disease too, but we didn't accept those donations. And the reason is that if you start picking specific diseases to focus on, then now you've really sort of gotten off of the strategy that we have in the first place, which is that we're not going to, quote unquote, pigeonhole ourselves into one disease or one drug and try to find a match for it. If we can look across all drugs and all diseases, we massively increase our likelihood of finding matches.
With the obvious private funding obstacles, David explains that Every Cure sought a different funding source and found one with the Advanced Research Projects Agency for Health, or ARPA-H, which is now Every Cure's largest funding partner. A government agency established about 2 years ago, ARPA-H's mission is to support projects that have the potential to revolutionize healthcare and improve health outcomes on a broad scale. Every Cure certainly meets that criterion.
We applied for funding from ARPA-H within a couple weeks of it even opening up. We've had this idea and we were, ready to submit basically the moment that they opened up the shop. They've been an amazing partner and we're thrilled to be working with ARPA-H. They're not just a funder, but they're truly a partner in every sense of the word. So they're our primary funding source right now. We also are really excited to be partnering with pharmaceutical companies to understand what are the diseases that those companies were already thinking about for that disease. Some companies will consider between 10 and 40 different diseases for a given drug. We want to understand and build partnerships with drug companies to understand what are those diseases that you thought about for that disease, but you never were able to pursue. What were the diseases where it emerged right before the drug went off patent that drug probably would work for that disease, and you never had the opportunity to study it? We want to work with you all. We want to establish a handful of key partners, and there's a few companies that we're progressing these partnerships along with, to be able to understand what are those additional diseases that you thought about but never could pursue. we as Evercure would love to pursue them. We'd love to build upon the billions of dollars that your company invested, the probably millions of hours collectively that your employees invested into these drugs to help to make sure that they're used for all the diseases and all the patients that they can possibly treat. I want to do everything we can to get our hands on as much data as possible. And anyone listening who's a part of a healthcare company, I hope you'll reach out to us at info@everycure.org if you're interested in donating your data in some way. We'd love to talk to you about it.
I want to thank David for not only sharing his extraordinary story, but for turning his personal struggle into hope with the founding of Evercure. We encourage our listeners to find out more by visiting everycure.org. David's personal journey is chronicled in his book, Chasing My Cure, now available in paperback. If you liked what you heard today, be sure to let us know with a review. And remember to follow us on X, Facebook, and Instagram at I Am Biotech. I'm Teresa Brady, and I produced this episode with help from Courtney Gastineau. It was engineered and mixed by Jay Goodman, with theme music created by Luke Smith and Sam Brady.